so today we're going to look at IXL X.1, theoretical and experimental probability. Alright, so first probability is how likely is it something's going to happen. Does it happen half the time? Does it happen 25% of the time? Does it happen 6 out of 8 times? Right? Probability, how often does it happen? When we write out, this is the proper way to write a probability statement. Right? You write P and a parenthesis. In this parenthesis, you're just talking about what you want. Do you want even numbers? Do you want odd numbers? Do you want numbers divisible by 2? Do you looking for the red marble or the blue marble? Whatever it is you're looking for, that's what you put there. Over here, you put equals and then whatever the answer is that you get. When you read it, you'd say the probability of red marbles equals 5 out of 7. And that's what you put, right? When you talk about theoretical and experimental, theoretical means you're just thinking about the answer and kind of just thinking about it in your head. Experimental, you actually go out and do whatever it is you're talking about, right? So, we're going to look at an example. So we're going to do this one. It says, you pick a card at random, what's P of prime? So what's the probability of getting a prime number? So I rewrote it over here, right? Prime number just means that you can only divide by itself. You can't divide it by any other number. Right? So if we look here, 4, I can divide 4 by 2, means it's not prime. 5, I can't divide 5 by anything. 6 can divide by 3, can't divide by 2, which means it's not prime. We got one of the things is prime, right? So if we look over, go back over here, the formula for probability is at the top, number of times your thing could happen. On the bottom, you put the number of total things. What's the total number of things that you could get? So over here, our total, we have 3 cards. So on the bottom, we'll have a 3. Now for prime only happened 1 time, so we're going to put a 1 on the top. Right? So we got that by putting the primes over the totals. Right? So when we're done here, we've got 1 over 3. 1 over 3 isn't going to reduce as a fraction, so that's going to be the answer. So in here, we're going to put 1 over 3. Terrific. Right? So let's look at this example. We've got a spinner, and you spin it, right? What's P of odd or factor of 32? Right, so we're going to spin the spinner. So if we spin the spinner, there are 4 sections on the spinner, right? So that means our total is going to be 4. All right, so on my paper here, I'm just going to write divide by 4. Because there's 4 things on the spinner, right? Like that, we had a 7, a 4, a 6, and a 5. So it said odd or factor of 32. So first, let's look how many odd numbers we have. I have 7 and 5. And then the other one was factor of 32. Just means that I can divide 32 by that number evenly. Alright, so we're going to test our numbers. So 32 divided by 4 is 8. So 4 is a factor. 32 divided by 7 is a decimal, so it's not that. 32 divided by 6 doesn't work. 32 divided by 5 doesn't work either. The only one that worked was 4. So now we're going to add these up. Since it said odd or factor, it's not allowed to be both. Now, none of our numbers repeated, so all of these are good answers. So we have 3 things that could happen. So 3 is going to go on the top there. Right, so our answer is 3/4. 3/4 does not simplify, so I'm going to put that in here. 3 over 4 is wrong because they wanted a percentage. Cool. So if they want a percent, just type this In the calculator, 3 over 4 is 0.75. To make it a percent, you go 2 spaces to the right, and then put a percent sign after it. 75%. Alright, so make sure you look out for that. So here, this one, simplify, write as a fraction. The other one said write as a percent. I didn't read that, so make sure you look out for that. Right, so remember, you want to put the total on the bottom and the number of things that you want on the top.